Welcome to our deep dive into the fascinating world of logic programming. We'll be looking at an article called Logic Programming, published on November 25th, 2024, by Mihigo E.R. Anasha.
Oh, cool.
Now, what I found interesting about this particular article is that Mihigo is both an author and a programmer.
Oh, wow.
So I think that adds a really interesting dimension to his take on logic programming. Logic programming is essentially using formal logic to define problems for the computer to solve.
Okay.
It's kind of like saying, hey, computer, here's the puzzle, here are the rules, now you put the pieces together.
Right. And the fascinating thing is that you're not actually dictating the how, just the what. You're not giving the computer like a step-by-step recipe. You're describing the outcome that you want using logic. And that's really, I think, what sets logic programming apart.
Okay, I'm intrigued. So how does that actually work? I mean, how do you describe a problem using logic?
Well, logic programs use a system of what are called clauses to represent facts and rules. And these clauses are like building blocks of knowledge.
Okay, so is that like if I said, all cats are mammals?
Exactly. That is a perfect example of a clause expressing a fact.
Okay.
And then you can build upon these facts to create rules. So you can say Fluffy is a cat.
Right.
And now the computer with those two clauses can deduce that Fluffy is also a mammal.
Gotcha. So it's about making these logical connections. I'm starting to see how this could be really powerful. The article gives this example: fallible X.
Yeah.
Human X. Can you break this down for me?
Sure.
Because at first glance, it looks a little bit like hieroglyphics.
Think of it like this. X is fallible if X is human.
Okay.
So that symbol, you can kind of read it as if. So it's saying if something is human, then it is fallible. And the beauty of this is that it can be read both declaratively stating a fact and procedurally like an instruction.
Oh, so it's like a 2-for-1 deal. You get the statement and the instruction all in one line of code.
Yeah, exactly.
That's pretty elegant. But I mean, isn't that a really simple example? Can logic programming handle more complex real-world problems?
Absolutely. And that's where the different flavors of logic programming languages come in. So there's Prolog, which has been around for a while, and then you have some newer languages like ASP and Daylog.
Okay. Now, the article mentions that Prolog has this, what's called a procedural element, while ASP and Daylog are purely declarative.
Right.
What is the significance of that difference? Does it affect what you can do with them?
It influences their strengths and how they're used. So Prolog allows the programmer some control over how the program executes, which can be really useful for certain tasks. You can kind of think of it like being able to fine-tune an engine.
Okay.
Whereas ASP and Datalog, they leave the entire execution strategy to the computer. So you're setting the destination and letting the computer figure out the best route.
Gotcha. So if I was interested in getting my hands dirty with logic programming, that distinction might help me decide where to start. If I like having more control, maybe I go with Prolog. If I'm more of a set it and forget it type of person, maybe I go with ASP or Datalog.
Exactly. And it also depends on the problem that you're trying to solve. Some tasks lend themselves better to a more procedural approach, and others benefit from the purely declarative nature of ASP and Datalog.
Right. Okay, that makes sense. So we've got these different languages, but what are the real advantages of using logic programming in the first place? The article mentions this idea of the ease of verifying the correctness of your code.
Right.
Can you elaborate on that?
Well, because you're essentially writing down logical statements. You can actually use formal methods to prove that your program is logically sound and will produce the desired results.
Wow.
Which is something that's much harder to do with traditional programming languages. Because in those, you're more focused on the how to achieve a result rather than what the result should logically be.
Right. So it's kind of like you've got like a built-in logic checker. But doesn't that only really apply to simple programs, though? I mean, real-world systems, they're messy and complex.
Yeah, you're right. It's not a silver bullet, especially with large, complex systems. But even then, the declarative nature of logic programming can help make the logic behind a program more transparent, more understandable, and easier to spot potential errors or inconsistencies.
Okay.
Plus, the source mentions Prolog having this really cool, unique execution mechanism that actually allows for efficiency improvements.
Oh, now that's interesting. So how does Prolog manage to be both logical and efficient? I feel like those are two things that are usually at odds with each other.
It's because Prolog's execution model actually allows for a lot of clever optimization techniques. So, for example, it uses something called backtracking to explore different solution paths intelligently and quickly eliminate any dead ends and find the most efficient solution.
So it's like having a built-in navigator that can like dynamically adjust its route to avoid traffic jams?
Yeah.
Okay, so it's not just sitting there pondering the mysteries of the universe. It's actually got some tricks up its sleeves to get things done. But how does this all translate to the real world, though? Where does logic programming really shine outside of these kind of like theoretical examples?
Well, that's where things get really exciting.
Yeah.
So think about fields like artificial intelligence, especially areas like knowledge representation and expert systems. These rely heavily on representing complex relationships and rules, which is something that logic programming is tailor-made for.
So we're talking about AI that can actually think logically. It's not just about algorithms crunching numbers. It's about encoding knowledge and reasoning about the world.
Exactly. And that's where the logic in logic programming really comes into play.
Right.
And what's exciting is that this logical approach could potentially lead to more transparent and trustworthy AI systems. If we can clearly express the logic behind an AI's decisions, it becomes easier to understand its reasoning and identify any potential biases or errors.
Right. That's a powerful thought. You're kind of lifting the curtain on the black box of AI and making it more accountable in a way. So logic programming, it might seem like this kind of niche topic, but it really does have the potential to impact some really major fields.
Absolutely. And we're really just scratching the surface here. There's a whole world of possibilities waiting to be explored with logic programming.
Well, I'm definitely ready to dive deeper into that world. I think we've covered the basics of logic programming, but I'm really curious to learn more about some of its specific applications and what makes each of these languages unique.
Let's do it.
Sounds good to me. Let's continue this deep dive.
Let's start with data analysis. You might be surprised to learn that logic programming can be a really powerful tool for working with data, especially when you're dealing with complex relationships and constraints.
Really. I have to admit, when I think of data analysis, I usually picture spreadsheets and statistical software, not logic programming.
Yeah.
So how does it fit into that world?
Well, imagine you have a large data set with information about customers' products orders. Now, traditional database systems, they're great at storing this data, but they often struggle with expressing complex rules or constraints that might govern your business logic.
Like customers who purchase product A are more likely to be interested in product B.
Exactly. That's a rule that you could easily encode using a logic programming language like Datalog.
Okay.
You're essentially adding a layer of intelligence to your database, allowing it to reason about the data and infer new insights.
So instead of just querying for raw data, you could actually ask questions like, which customers are most likely to churn based on their purchase history and browsing behavior?
Yeah.
And have the database logically deduce the answer.
That's the idea. You're moving beyond simple data retrieval and into the realm of knowledge discovery. And because these rules are based on logic, you can be more confident in the validity of the insights that you uncover.
That's a huge advantage, especially when you're making, business decisions based on that data. It's like having a team of expert analysts built into your database. Are there any like real-world examples of this in action?
Absolutely. Datalog in particular is gaining a lot of traction in fields like fraud detection and risk management. So, for example, financial institutions are using it to analyze transaction patterns and identify potentially fraudulent activity based on a set of predefined rules and constraints.
So if I was working in finance trying to catch those sneaky credit card fraudsters, Datalog could be my secret weapon. It's like having a logic-powered security guard on duty 24/7. That's pretty cool. But what about other areas beyond data analysis? Where else is logic programming making waves?
Another fascinating area is natural language processing, or NLP for short. This field is all about enabling computers to understand and interact with human language. And as you might imagine, logic plays a crucial role in deciphering the complexities of language.
Yeah, that makes sense. I mean, human language is full of nuance and ambiguity. It's not just about understanding individual words, but their relationships and how they combine to form meaning. That's where the logic comes in, right?
Precisely. Logic programming allows you to represent grammatical rules and semantic relationships in a way that computers can understand. So, for example, you could define rules for how subjects and verbs relate to each other in a sentence, or how pronouns refer back to their antecedents.
So if I'm building a chatbot that needs to understand and respond to human language in a meaningful way, logic programming could be a valuable tool.
It certainly could. It's been used to build systems that can parse sentences, extract meaning from text, and even generate natural-sounding language.
Wow, that's impressive. It seems like logic programming is a lot more versatile than I initially thought. Are there any other kind of unexpected applications that we haven't touched on yet?
Well, think about scheduling and resource allocation. These are problems that pop up everywhere, from airlines planning flight routes to factories optimizing production schedules. And you guessed it, logic programming can be used to tackle these challenges as well.
I'm starting to see a pattern here. Whenever you need to define clear rules and constraints and find the best solution based on those rules, logic programming seems to be a good fit.
You've hit the nail on the head. Logic programming excels at problems that can be expressed as a set of logical statements and constraints. And what's interesting is that this approach often leads to solutions that are not only correct, but also easy to understand and verify.
Right. It's not just about finding a solution, but finding one that makes sense logically and can be easily explained to others. That's a big win, especially when you're dealing with complex systems or making decisions that impact people's lives.
And that ties back to one of the fundamental benefits of logic programming that we talked about earlier, this ability to verify the correctness of your code,
Hmm.
which is particularly crucial when you're building systems that require a high level of trust and reliability, like medical diagnosis systems or autonomous vehicles.
Oh, yeah. I mean, the idea of a self-driving car powered by logic programming, that's both exciting and a little bit unnerving. I mean, I would want to be absolutely sure that the logic behind its decisions is sound and free of any errors or biases.
That's a valid concern. And it highlights the importance of rigorous testing and verification in any safety-critical system. But the good news is that the formal foundations of logic programming provide a strong basis for ensuring correctness and building trust in these systems.
So while there are always risks involved with any new technology, logic programming offers a way to approach these challenges with a level of precision and transparency that's often lacking in traditional programming paradigms.
Exactly, and that's what makes it such an exciting field to watch. As we continue to push the boundaries of what computers can do, logic programming offers a powerful and principled way to build systems that are not only intelligent, but also understandable, verifiable, and trustworthy.
Well, I have to say I'm thoroughly impressed. We've gone from what is logic programming to exploring its applications in data analysis, natural language processing, scheduling, even AI. It's clearly a field with a lot to offer. But I'm curious, are there any downsides or limitations to using logic programming? Is it like a perfect solution for every problem?
That's a great question. And it's important to acknowledge that logic programming isn't a magic bullet. Like any tool, it has its strengths and weaknesses. And it's not always the best choice for every task.
Okay, so let's talk about those limitations. What are some of the challenges or drawbacks that someone might encounter when working with logic programming?
One common challenge is that logic programming can sometimes be less efficient than traditional imperative programming languages for certain types of tasks.
Okay, so while Prolog has those optimization tricks we talked about, there might be situations where a more traditional language would simply be faster.
That's right. Especially when dealing with tasks that involve a lot of low-level manipulation of data or require very precise control over the execution flow, imperative languages might have an edge.
That makes sense. It's like using a scalpel for surgery versus a hammer for construction. Each tool has its purpose. But are there any other limitations beyond efficiency?
Another challenge is that logic programming requires a different way of thinking about problems. It can take some time to get used to expressing problems in terms of logical statements and rules, especially if you're coming from a traditional programming background.
So it's not just about learning a new syntax, but also adopting a new mindset.
Exactly, it's a paradigm shift. And it can be a bit of a learning curve for some people. But once you grasp the fundamentals of logic programming, it can be an incredibly powerful and rewarding way to approach problem solving.
You've certainly convinced me of that. We've seen how logic programming can be applied to a wide range of fields and challenges, and we've discussed both its advantages and limitations. But I'm curious, where do you see logic programming going in the future? What are some of the emerging trends or exciting developments on the horizon?
That's a fascinating question, and I think we're just at the beginning of what logic programming has to offer. One area that I'm particularly excited about is the intersection of logic programming and artificial intelligence.
We already talked about how logic programming can be used for knowledge representation in expert systems, but are there other ways that these two fields are converging?
Absolutely. There's a growing interest in using logic programming as a foundation for building more transparent, explainable, and trustworthy AI systems.
Mhm.
The idea is that by grounding AI in logic, we can make its decision-making processes more understandable and accountable.
That sounds promising, especially given the growing concerns about the black box nature of many current AI systems. But how would that work in practice? Can you give me an example?
Sure, imagine a medical diagnosis system built on logic programming. Instead of just spitting out a diagnosis based on a complex neural network, it could actually provide a step-by-step explanation of its reasoning, tracing its logic back to the original data and rules that led to its conclusion.
Okay, that would be a game changer. Not only would it increase trust in the system, but it could also help doctors understand the rationale behind the diagnosis and make more informed decisions. Are there any other promising areas where logic programming is making inroads?
Another exciting area is the development of new logic programming languages and frameworks that are designed specifically for modern computing challenges like cloud computing, big data, and the Internet of Things.
So it's not just about applying existing logic programming techniques to new problems, but also creating new tools that are tailored to the unique demands of these emerging technologies.
Exactly. The field of logic programming is constantly evolving and adapting to meet the needs of the ever-changing technological landscape. And I believe that we'll continue to see innovative applications and exciting breakthroughs in the years to come.
Well, you've certainly painted a compelling picture of the future of logic programming. It's clear that this is a field with a rich history, a vibrant present, and a bright future. But before we wrap up our deep dive, I'm curious to get your personal take on the significance of logic programming. What is it about this field that captivates you and makes it so fascinating to explore?
For me, the beauty of logic programming lies in its elegance and its ability to bridge the gap between human reasoning and computational power. It allows us to express complex ideas in a concise and precise way, and it empowers computers to reason about those ideas in a manner that's both powerful and understandable. It's a field that encourages clear thinking, rigorous analysis, and a deep appreciation for the power of logic.
That's a beautiful way to put it. And I think it captures the essence of what we've explored in this deep dive. Logic programming is not just about writing code. It's about understanding the world around us, expressing that understanding in a formal language, and harnessing the power of computation to draw meaningful conclusions and make informed decisions.
You summarize it perfectly. And what's most exciting is that this approach has the potential to impact virtually every field of human endeavor. Whether you're working in science, engineering, medicine, finance, or any other domain, logic programming offers a powerful set of tools and a unique way of thinking that can help you solve problems, uncover insights, and create innovative solutions.
I'm certainly inspired to continue exploring this fascinating world of logic programming. We've covered a lot of ground in this deep dive, but I feel like we've just scratched the surface of what's possible. Is there anything else you'd like to add before we wrap things up?
Just that I encourage everyone listening to dive in and explore this field for themselves. You might be surprised by what you discover and the creative ways you can apply logic programming to your own areas of interest.
That's great advice. So for anyone listening who's feeling inspired to learn more about logic programming, where would you recommend they start?
Well, the article we've been discussing mentions Prolog, ASP, and Datalog as good starting points. There are plenty of online resources available, including tutorials, courses, and open-source implementations of these languages.
That's helpful. So whether you're a seasoned programmer or just starting your coding journey, there's a path for you to explore the world of logic programming. And who knows, maybe you'll be the one to apply this powerful paradigm to unlock the next big breakthrough in AI data analysis or some other field we haven't even imagined yet.
The possibilities are truly vast. And as Mihigo Anaja reminds us, logic programming is a field where both theoretical beauty and practical applications can coexist and even enhance each other.
Yeah, it really is amazing to think about how logic, something that we usually associate with like philosophy and mathematics, can be harnessed to power these like real world applications. And it sounds like this field is like constantly evolving.
Oh, it absolutely is.
What's really striking to me is how the source kind of subtly highlights this human element within this very technical field. Remember Mihigo Anasha, the author of our source article? He's not just a programmer, he's also a writer.
Right. Yeah, that's a good point. It reminds us that even with a system as precise as logic programming, there's still this room for human ingenuity and insight. It's not just about this cold, hard logic, It's also about the creativity that's needed to apply that logic in meaningful ways.
Exactly. And, that leads to an interesting question that the source kind of indirectly raises but doesn't explicitly address. Could this declarative nature of logic programming, where you focus on stating what you want to achieve rather than how to achieve it, could that lead to more transparent and understandable AI systems in the future?
It makes you wonder if we could program AI using logic that's easy to understand and verify. Could we potentially address some of those concerns around the black box nature of AI and maybe make those systems a little bit more aligned with human values and reasoning? It's a thought-provoking question, and one that's worth considering as we continue to explore the possibilities of logic programming. For our listeners who are intrigued by this approach to problem solving, I encourage you to dive deeper into the world of Prolog, ASP, or Datalog. You might be surprised by what you discover.
So there you have it, folks, our deep dive into the world of logic programming. We unpacked the basics, explored its real-world relevance, and even pondered some thought-provoking questions about the future of AI.
Until next time, keep those minds curious and those explorations going.